In this video, we're going to see how we can measure the accuracy of forecast, and we're going to see how we can use forecast accuracy in order to compare different forecasting techniques. We're going to use data file gasoline for computational purposes. There are different ways that we can measure accuracy of forecast. But first, we need to understand the definition of forecast error. So we usually make a forecast for something that is going to happen in the future, right? So we make a forecast for, let's say, sales at period T, at week T, month T, at period T. And then when we reach that time, when we reach period T, we observe the exact value or the actual value of sale at that time. The difference between these two values, the actual value of sale versus the forecasted value of sale, this is called forecast error at period T. All right, so this is forecast error, and we have it for every single period. And this thing, the forecast error, can be negative or positive. If it's negative, it means that we have overestimated the sales or the variable of interest. If it's positive, it means that we have our forecasting technique has underestimated the sales or the variable of interest, all right? So for each period, we have this, but we need to combine all these forecast errors at different periods in order to be able to come up with one quantitative measure that can be used for comparison, for comparing different techniques. The first way that you can combine them is to actually get the average of forecast error. This is, even though it's very simple, it's not a great idea. The reason for that, it's really not a good measure. Nobody uses it. The reason for that is that it's the forecast errors can be positive and negative. If you do this, the positive and negative numbers are going to cancel out each other, and MFE is going to be very close to zero in most cases. MFE is going to be very close to zero. It doesn't truly show the accuracy of the forecast. It doesn't show the error. It doesn't show the deviation from the actual numbers. So that's really not a good forecast accuracy measure. Instead of that, if we just make sure that all the forecast errors, the absolute value of them are considered in finding the average, in finding the error measure, forecast error measure. And if we just take the average of absolute values of errors, we get a measure that is called mean absolute error, average of absolute errors. That's a much better, that's a very common forecast accuracy measure. Alternatively, we can, instead of taking the absolute values, we can take squared forecast errors and use the average of errors squared to actually use as a measure for forecast accuracy. This whole thing is now called mean squared errors, MSE, right? Next, MAPE, mean absolute percentage error, MAPE, and that is simply taking, it's very similar to MAE, mean absolute error, except that instead of taking the average of absolute values of errors, we take the percentage of error by dividing error by error divided by the actual value at period t. That would give us the error in like percent error in forecast of period t. And we just take the average of the absolute values of these percent errors, and that would give us the mean absolute percentage error. All right. So now I'm going to use the same data file that we worked on, the gasoline data file, and we're going to find some of these like forecast error measures in order to compare these forecasting techniques. So there are a lot of, we did actually 4 methods here: naive, past average, moving average, and exponential smoothing. Since the process is very similar, like once we know how to find MAE, really doesn't matter for which one of these we're doing it. Once we understand how to do that, that's going to be very simple to generalize it and use it for different techniques, as long as you have all these numbers, all these forecasts and the actual numbers, and as long as you can find the forecast error. Because of that, I'm just going to focus on exponential smoothing and moving average with k equal to 3. And I'm just going to measure the errors for these two, just to make sure that we're not changing anything on this sheet. I'm gonna copy the whole sheet and paste it in a new cell, in a new sheet, and I'm gonna call it forecast accuracy. All right, and I'm gonna get rid of the naive and past average. So I have moving average for the 3-week moving average, and I have exponential smooth. All right, I'm just gonna get rid of these formulas for now. All right, now we have actual numbers and 2 sets of forecast. Moving average with k equal to 3, 3-week moving average, and exponential smoothing. And now we want to find, I'm just gonna do this, MAE, MSE, and MAPE. So we want to find the 3 for you. We don't really need to measure all of these. Usually for exam questions, you just need to do it for one, like using one of these forecast accuracy measures. You just need to find that, and we usually do it for MSE. So this is usually more common than the other two. MAP is also very common. I'm just gonna do it for basically demonstration purposes, but it doesn't really matter. And the results should be more or less the same. We'll see actually if they give you the same recommendation at the end of the day. So MAE is going to be, we just defined it as average of absolute values of errors. So that's just the definition of MAE. And I'm going to go ahead and do it for moving average and for exponential smoothing. I'm just going to write it, paste it here, and that way we can, all right. So moving average, just making sure that everything is coming up nicely. MAE, average of absolute errors. So for MAE, what we need to find would be the absolute value of errors. All right, so we need absolute errors, and then we just take the average of these absolute errors, and that would give us the MAE. So I'm just gonna make sure that everything is all right. Average of absolute values of errors. So I have absolute of errors, and that would be ABS, absolute value of error. An error is sales, actual value of sales, Y minus Y hat, or A minus A of T minus F of T, A minus F, actual minus forecasted value. All right, so that's the absolute error. And we just do it for every single one of these periods for which we have both actual sale and both moving average. You don't need to do it for the first three. You don't need to do it for, you can't do it for week 13 because you don't have the actual number. You just do it for all periods that you have the number. And then, so that's the absolute error. We just find MAE of moving average to be average of all these numbers. 2.63. And I'm just going to show you the formula again for the first one, for absolute value of error. So that's it. Very simple. 2.69 is the MAE of moving average. I'm just going to go ahead and add two more columns. One for, so we just did it for MAE. I'm just going to bring it back here. I'm just going to find MSE and MAPE for this one, and then we're going to do it for the exponential smoothing, and then we can make comparison. So MAE and then MSE is average of error squared. So error squared. So for this one, I need to find error squared, and then I just take the average, all right? So error squared is going to be error, and error is actual number minus forecasted value squared. Everything is squared. And again, I just drag it down all the way to period 12, guys. And that would be it. I can just find the average, and that would be, let me just put it here. This one is MSE of moving average. And again, just to show you the formula. All right, so MSE of moving average is now 12.22. So moving on, MAPE would be average of absolute value of error divided by actual number, A. Actual, I just type actual, error divided by actual in percentage. I mean, you just need to multiply it by 100 just to show it in percentage. But I'm not going to do it because in Excel, percentage is just a format. As long as you have a number that is less than, doesn't really matter. As long as it's less than 1, it's going to be a number less than 100%, but that's not going to change anything. Absolute value of percentage of error divided by the actual number. So let's just get that percent error. So we need to find percent error, and that would be the error divided by, error would be actual number minus forecasted number, actual number minus forecasted number divided by actual number. And then the whole thing, I said absolute value of error divided by actual, but then absolute, and then I need to add absolute percentage error. I need to add that here. So absolute percentage error. All right, and now I can just drag it down all the way to period 12. Again, only period 12. I won't be able to do it for period 13. I'm gonna highlight this row, period 13, just so we know that this is where we want to make a forecast. So now I have the absolute percentage error, and this is the formula for this one, for the first one. And I can just drag the formula here, which would be simply the average of all these absolute percentage errors. And that would be MAPE for moving average. MAPE or MAPE for moving average, that's 14%. If you want to change all these numbers into percentage format, you can just change it to go to Home tab and press on percentage format. And we see that on average, our forecast has 14% error. On average, 14% error. So that's the easiest one to interpret. The other ones, especially this one, MSE, is hard to interpret. So we just found the error. Let me just put it in a thick outside border. So we just found the error for moving average. We're gonna do exactly the same thing. We're gonna find MAE, MSE, and MAPE for exponential smoothing, and then we're gonna make a comparison between these two. So let me just show you the formula. This was MAE, MSE, and MAPE. The formula was a simple average of absolute error, error squared, and absolute percentage error, respectively. So and now I'm gonna do exactly the same thing. I can go ahead and type all these formulas, or I can just copy from here and paste it over here. I can do that, except that I need to adjust my formulas if I wanna copy my formula. First of all, I need to add 2 more columns, and you know what? I'm gonna copy and paste my formulas here, and then I'll change the exponential MAE to exponential smoothing. But for that, I need to adjust my formula. So I need to make sure that sales, the value of sales, is not going to change when I paste my formula over here. So how do I make sure? And you see here, B5, B6, B7, it should not change when I copy my formula from here and paste it here. So how do I make sure that B5 is not changed? I just add a $sign only before B. So that way the formula is going to be adjusted, and if I just copy it from here and paste it right in front of this one, look what happens. So it's going to be absolute value of B5 minus G5, the error at this one, the actual forecast. So not only B, but also C. I should also fix C, because you know what, not C, it should be, no, that's good, not C. So only B. And then I'm good to go. I can just drag my formula, making sure that they're all adjusted. Again, B, $sign, and then drag it down all the way. Add B, $signs for B. If you feel that this is complicated, you don't have to do it. You can type the formulas. The process is exactly the same as what we just did. So, but I believe this is a little faster. So I'm gonna take everything now. This whole thing, Control C, and paste it here. Always make sure that you have all the formulas are coming up right. So let's say for this one, it's the absolute value of actual number minus the forecasted value. So that is divided by B13, the actual value at period 12. So that's good. Maybe one more. This one, error squared. Error would be actual minus forecasted value for exponential squared. The only thing that we need to change is the label here, exponential smoothing, and then exponential smoothing. All right. And now let's just go ahead and do the comparison. So based on, now when you measure the forecast errors for, let's say, two techniques, the one with the lower error is expected to give you a better forecast in the future as well. So what we are doing here, we're looking at past observations, we're comparing past forecast versus past realization of the state. And we're measuring average error. Basically what we're doing here, we're measuring average errors. And now we've done it for two techniques. The one that gives you a lower error is expected to give you a lower error also in the future. So it's gonna hopefully stay the same. The error is not gonna increase in the future, right? MAE, when we're comparing moving average versus exponential smoothing, we just need to look at these two numbers. I'm just gonna highlight those. Highlight these two numbers in, let's say, green. These two numbers. MAE of moving average is smaller, so moving average is preferred based on MAE. So if I ask you what is your forecast, if I ask you to find MAE and then give me your forecast for the next period. So you just find the MAE of exponential smoothing, MAE of moving average. The one that gives you a lower error, average error, MAE, lower MAE, would be a preferred technique. And then the forecast that this one provides, moving average, This one would be the preferred or recommended forecasted value. That is actually estimated using the moving average technique. So MA moving average is preferred based on MAE, based on MSE. Exponential smoothing is now more preferred because the number here, we have 9. Let me just highlight these two numbers, maybe in another color, blue. And exponential smoothing is preferred based on MSE. And then based on MAPE, they're pretty close, but let's just add, maybe let me change first the color, and then let me add some more decimals. They're pretty close. They're very close, actually. This one is slightly more accurate than this one. So almost the same, but if you want to be really picky, moving average is preferred based on MAPE. Almost no difference, right? So this is what we, yes, this is what we conclude based on the measures of error. One last thing before we move on. One thing that is important here, as you can see here, they're giving us different indications as which one of these techniques are better. And remember, this is not, even though we use exponential smoothing, this is not a general result. It depends, exponential smoothing it absolutely depends on the value of alpha. If you change the value of alpha to 0.2, let's see what happens. Everything is now significantly lower than, if you go with alpha 0.2, it's better than alpha 0.3, and it's always better than moving average. You see, all these three numbers are less than their corresponding the same numbers at the other side of the for moving average. All right. So it's highly dependent on the value of alpha. I'm going to change it back to 0.3. But you see what I mean here. And then same thing for moving average. If you change K to 4, 5, the accuracy might increase, might decrease. It may change, right? That's my point here. So they're dependent, both of them, on the value of their parameters, the number of periods that you use, the value of alpha that you use. One last thing before we wrap this up, I just want to see the impact of alpha. In this specific case, we saw that if you decrease alpha, it increases the accuracy of your prediction. But let's see if that is the case also visually. I'm just going to visualize the actual numbers versus the forecasted numbers. And then here, I mean, this is a little harder to change, but alpha, we can simply change it and see the impact on the forecast. So if I want to visualize it, I can go ahead and do these two, sales and moving average. If I just add a line chart, line with markers, I have sales and I have the moving average. All right. So sales, the blue one, and the moving average. I just need to add the exponential smoothing. In order to add a data series, I can right click on this graph, select data, here, add data series. Series name is going to be exponential smoothing. Series values, G2 to G13. So you just want to make sure that you're using the same rows, actually the numbers at the same rows, just to make sure that everything will be compared with their exactly with their corresponding numbers. All right, so exponential smoothing, moving average, and the actual value of sale. Okay, so this is what we have here. And I'm just gonna get rid of the grid lines again. All right, so the blue one is the actual sale. The green one is exponential smoothing. The red one is moving average. What I can do, the nice thing about this one, at least for exponential smoothing, is that I can change the value of alpha and see the change on my forecast in real time. So if instead of 0.3, I decrease it to 0.1, see what happens to my green line. It got flatter, right? It got actually flatter. It's not fluctuating as it was before if we decrease alpha. So alpha, even though it's called smoothing factor, it's actually by removing it, you're making the line flatter. And by increasing alpha, if I go ahead and put 90%, if I go ahead and put 90%, you see that it gets now fluctuating a lot, right? It's now more volatile. And if I put alpha equal to 1, it gets exactly equal to naive forecast. So moving out, exponential smoothing, when alpha is 1, let me just show you why. Moving out, exponential smoothing, if alpha is 1, it means 1 minus alpha is 0. So this is going to go away. Then the forecast will be FT is equal to 1 times A minus A of T minus 1, which is exactly the same as naive. Moving average, when K is equal to 1, is going to be, again, the same as naive. Moving average, K equal to 1, would be the same as naive. Moving average, K equal to 1, will be the same as exponential smoothing when alpha is 1. So that's, and then naive is the most fluctuating, most variable forecast that one may have, right? Naive is the most fluctuating. So by increasing alpha, you're increasing the fluctuation, the variability in your forecast. And by decreasing it, you're making your forecast less dependent on the recent observations and more on the past observations, on the average of past observations. So that's really what we are doing here. So I'm just going to change it to 0.3.